Hello and welcome to my explanation of resistance. This is electrical resistance. So firstly, what does resistance mean? Well, it means when you try to stop something, if you try and resist someone, you try and stop them. So it's really the same with electricity. If something tries to stop electricity flowing, it has a resistance, but it has an electrical resistance. But what does that actually mean in terms of the particles, the atoms, the material itself? So we're going to talk about a typical material such as a metal. We're going to look at high resistance and low resistance material. So here is a low resistance material. Let's see what happens as the red electron moves through it. Let's see that one more time. So what is happening here? The electron is moving through the material, and every so often it hits one of the atoms or the ions and it bounces off them. But you can probably guess already, every time it bounces off one, that's the material trying to stop it moving. So you can probably guess that the more times it bounces off, the higher the resistance. So now let's look at a high resistance material. So this is a high resistance material. What's different? Well, you can see there's many more collisions. You can see how much more wiggly the path of the electron is. You can see that actually it probably takes a little bit longer to get from one side to the other. So what is resistance? Well, resistance is the collision of the electron with the atoms. And the more collisions there are, the more resistance there are. In the first example, there are not many collisions. It's a low resistance. In the second example, there are many collisions and it's a high resistance. So let's think. Supposing we made this wire longer, what would happen? Well, there's obviously going to be many more atoms all in a row. So if there were many more atoms in a row, the electron has to go through even more. There's going to be more collisions. There's going to be a higher resistance. Supposing we made the wire wider, well, in that case, there would actually be more space for the electron to move. It would probably look maybe a bit more like this. There's more space and it can get through with less resistance. So a wider wire means less resistance. And then finally, supposing we heated up the material, what would happen to the resistance? Well, now all of the atoms would start to vibrate more because as things get heated, the atoms vibrate more. And if the atoms are vibrating more, the electron is going to find it harder to get through because there's going to be a greater chance of the atom hitting the electron. And when they do hit the electron, they're going to hit it with more energy and they're going to be able to resist it much more forcefully. So let's summarize all this on a slide. Resistance is caused by collisions between electrons and metal ions. A longer wire or resistors in series means a higher resistance as there are more ions to move past. A thicker wire or resistors in parallel means a lower resistance because there is more space for the electrons to move. And a hotter wire means a higher resistance as the metal ions vibrate more and are more likely to collide with the electrons. If you just remember those two animations in this slide, you are able to answer a huge amount of questions and you have quite a good understanding of resistance. Now, they might ask you for a formula or to do some calculations. So we're going to look at the formula. This top formula here is the formula you need. Resistance is potential difference divided by current. What are the two other formulas on the screen? Well, let's look at them. The second formula here is an easy way to remember it. It's not what you'd write down on the exam. This is some informal language, but it helps us to understand what resistance is. Push is like the energy required to move something, or in terms of electricity, is the potential difference or the voltage. It's also similar to the force. Okay, if you push something, you push it with a force, potential difference or voltage is sort of like the force pushing it round. Current is what is moving, it's what is flowing. Or you might think of it as something moving in terms of it accelerating, getting faster. If you push something, it will get faster. Now, the ratio of these two, the ratio of push to flow, the ratio of force to acceleration, the ratio of potential difference to current is how easy or how hard it is to move. And that is known as the resistance. What about if you push something with a physical force and it accelerates? We don't talk in terms of resistance, but we talk in terms of mass. Mass in kilograms means that something doesn't really want to move. It just wants to stay there. And how much it wants to stay there depends on how big the mass is. Technically, we should be using the word inertia, but we won't worry about that in this video. So if you need a large force to make something move, it must have a high mass. If you need a tiny force and it moves a lot, it must have a tiny mass. What about electrical resistance? If you have a really high push and nothing really moves, then it must have a high resistance. If you have a small push and it moves a lot, you must have a low resistance. Same as for the actual exam definition. If you need a lot of potential difference and you don't get any current, there must be a high resistance. If you have a tiny potential difference, but you get a lot of current, then you must have a very low resistance. So that's summarized here nicely, okay? High potential difference, small current, very small resistance. Sorry, very high resistance. If you have a high push and a small flow, you get a high resistance. Let's look at the low resistance. A small potential difference, but a large current means a low resistance. If you need a small push and a high current or high flow, then you have a very low resistance. A tiny bit of extra information for you. We measure resistance in ohms using this funny symbol here, the Greek symbol omega. 1 kilo ohm is 1,000 ohms. We use this all the time because often resistances are quite big. And finally, the symbol for a resistor is this box here with two wires coming off of it.